So if I ask, what is the return type of the function? And then I list int or string, what is the return type? I hear a lot of people saying C. Is it going to return a string? No, C is the string is the input. It's what's being passed into it. It's the parameter type. So the return type of the function is int. And the parameter type is string. All right, and this is more like review from the last exam, but for some reason I had the questions on there. What's the special character that starts a preprocessor directive?
Hash.
The hashtag, yeah. True or false? Preprocessor directives end in a semicolon.
No.
I wish I could spell preprocessor. And we have mentioned this a couple of times, but it wasn't on the quiz. If we have a namespace, like underneath # include, whatever we include up at the top, and then we had namespace myData, and we stuck our variable in there. I actually think I'm going to remove this question, but if I don't, you're going to know what it is. And then down here in main, how would I access those variables? If I wanted to set x equal to 10 down here, what would I need to do?
What do you have to call it?
I have to do this, myData : x is equal to 3. I can get away with not doing that if I do this, using namespace myData. If I do using namespace myData, I can leave off that because we're assuming, or we're bringing all of these things into the default namespace, so we don't have to do that. That is why in our code we have been doing using namespace std. If we did not have using namespace std, then every time we use cin or cout or something like that, we would have to put std : in front of it. And I know I've mentioned it before, but some programmers studiously avoid doing the using namespace std. And the reason for that is that brings in a lot of things that might conflict potentially with other things that you want to declare, because the std namespace is actually very large and got a lot of different members in it. These are all over. Oh, we no wonder it's looking wrong. We didn't cover chapter 5's quiz. Yeah, let's go do that. I knew something was starting to look odd. I assume one of y'all will tell me if you can access or cannot. Alright, what will x equal? This looks easier than it actually is. A lot of people went for 4. but it's actually 3. The reason why is that if the plus plus follows the variable, then it doesn't get incremented until the line is done. So when this code is done, y will still equal 3 and x will equal 4. However, if the plus plus comes before the variable, it's the first thing that gets done. So here, the plus plus is the first thing that happens. So s changes from 4 to 5, and then that gets copied into b. So b is 5. But up here, it's the last thing that gets done. So 3 gets copied into y, and then 3 turns into 4. So y equals 3. X equals 5. Does that make sense? I know like half of y'all missed it, so that's why I'm asking. Half of y'all aren't looking at me. You're ashamed. No, I'm kidding. You're checking Facebook. I know you. Let's see here. Here's our while loop. Assuming this is coded correctly, how many times would it print? Well, it's going from 0 up to, but not including 10. You just have to count it out on your fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I did something wrong. Yeah, that's 10. It's done now. So it printed hello 10 times. The next question, I think, was what happens if we change that to less than or equal to? No? Yeah, here it is. If it's changed to while x is less than or equal to, how many times would it print out? And the answer is 1 more. Because it would go up to and include 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually printing out 11 times. I think it'd be easier to count on your fingers if I had not made this 10, if I'd made it like 5, you know. Confuses me when I'm saying 0 and I have a 1 up there as a finger or whatever. Okay, so a while loop, pre-test or post-test? Pre-test. The do while is post-test. This is a while, not a do while. The test occurs at the beginning. So if we set x equal to 100, it wouldn't even go over here and do any of this stuff. It would immediately fall through because it's pre-test. Just like this. How many times will hello be printed? A is equal to 100 while A is less than 10. Is it going to even print it at all? No, it's not. But if it's a do loop, it will print it 1 time because the do loop, the body of the loop always executes at least 1 time because it's post-test. How many times will hello be printed? Same thing. It's going from 1 up to and including 5. So 1, 2, 3, 4, 5. If I'd started at 0, it would have been a different answer. There we go. 2 up to and including 10 by 2s. So 2, 4, 6, 8, 10. Actually printed out 5 times again. Write a loop that will add all the numbers. Now, unfortunately, when I gave this to y'all, it did not have the word add there. It said, write a loop that will all the numbers. So if you did not know what all meant, some people actually texted me and asked, what it was supposed to do is add the numbers between 1 and 10. So it's possible that some of y'all did not put the code that I'm going to show you here because you did not think that it was asking you to add them. In which case, take it again, change it, and get your point. So let's write it as a while loop. Total is equal to 0. We need to initialize total to 0 before the loop. And a for loop is the simplest of all. So for int x is equal to 1, x is less than or equal to 10, less than equal to 10, x plus plus. And inside the loop, we want to add x to total. So either total is equal to total plus x or total plus equals x, like that. That's what you needed for full credit. If you left this part out, you didn't get full credit. If you added print statements, cout statements, and stuff like that, you didn't get any more credit. I didn't give you bonus because I didn't ask for that. I said no CIN or cout. write the include statement that lets you use file streams. So here again, I messed y'all up by, in certain cases, telling you to add the include, and in certain cases not. So I think I dinged you half a point if you did not put the word include on here. So, # include F stream. What data type have we been using to open files for writing? OF stream. Yeah, you got them swapped. If you're reading the file, you use IF stream. The O stands for output file, you're outputting, you're writing. I stands for input file stream, you're reading from it. If you have a file named myfile, true or false? Well, it's true. There's more than one way to check to see if the file gets opened, but this is the way that the text illustrates. So, if you have a file variable named myfile, which of the following will write to it? Well, if you're trying to write to myfile, you have to do the arrow pointing to it. And you know me, I was always doing that, flipping it back and forth when I'm up here using CIN and COUT. So I have sympathy, but we had to do the arrow pointing to myfile.
Maybe two choices to that, because there's like a.
There's this one, but the arrows are pointing away from it.
What about the one above? Oh no. What about the one below A?
Well, this is totally wrong because the stream object has to go on the left-hand side.
Okay.
So it looks plausible, doesn't it? But we've never written any code that did X arrow into CN. You know what? Well, would that work? We have to make sure that that doesn't work. Okay, so for example, if we wanted to say hello, could we do this? Hello, arrow CN. No, we can't. It gives us an error. We have to put the stream on this side of it. And I don't know who made that rule. The programmers of the C++ streams dictated that, so B could not work. Opposite question, if you have a file variable named myfile, which will read from it? Well, if you're reading from it, the arrows go away from it. So myfile, arrow X. Write a line of code that will close myfile. Somebody put fclose. I had a lot of sympathy for that because that is how you close C file handles. And you can use C file handles in C++, but we've been using stream IO. And we can assume that we're using stream IO because I use the same myfile word that in the previous examples have been done as streams. So fclose is not, fclose myfile would not be correct in this case. Instead, we would want myfile.close. I think everybody got this one right. What keyword causes a loop to interrupt so that it bails out, it jumps to the next statement that follows the loop? Break. Which one causes it to be immediately repeated? Continue. And vast majority of people got this one right. The special value that marks the end of a series of input, that's known as a sentinel. And even if you didn't know that, yeah, everybody got it right, I think. Post-test loop is a do loop. A pre-test loop, somebody said while on this. And the reason while is not the right answer is because a pre-test loop that lets you specify the initialization, the test condition, and the update all in a single line. The while loop doesn't let you do all that. It is a pretest loop, but that was only part of the question. So that's a for loop. All right, any questions over this part? Nope. Okay. Back to where we were. So I didn't explicitly ask for this in the quiz, but there was an example, I think. Maybe, maybe not. Anyways, if I wanted to write a for loop that would count these numbers, 10, 20, 30, 40, 50, and I wanted x to go through all those values, help me write a for loop that does that. For, parentheses, what do I do next? I'm going to go ahead and use the word int. I'm going to make sure that it's been declared. And then I'm going to start at x at what? 10. And I want to keep going as long as x is what? I shouldn't put less than because it might not be less than.
Greater than.
Less than is correct, but it's only part of the answer. Less than or equal to 50 unless I put something else. I could make it x less than 51, something like that. And then what's the last thing I want to do here? X plus plus. That would count it starting at 10, and then it would go 11, 12, 13, 14, 15. Instead, I want it to go up by tens. X plus equals 10. If you wanted it to go up by twos, if we wanted y to go from 0 to 8 by twos, we would do for int y is equal to 0, y is less than or equal to 8, and then what? X plus equals 2, correct. All right, that's it. Did we talk about arrays last week?
No.
Was that a no?
Yeah.
Yeah? Why can't I find my notes for that?
I think you put them under PowerPoints or presentations or something like that, or videos. Might be videos. I just remember it took me a while to find it. Yeah, there they are.
Yeah, great. Okay. Time to make a Notes 3 folder. Pull those guys over into it. Thanks for remembering, and I apologize for having hidden them. There we go. And that doesn't show a thing about arrays.
Oh, okay.
But it still was in the wrong place. But that should have wound up in the Unit 2 notes. Starting to think I didn't talk about arrays, but y'all say I did.
You didn't.
Did not. Okay. All right. Then we will. Crank up a new Visual Studio project. Add a new class to it. I'm going to cheat and copy my boilerplate. Okay. So an array is a list of values. I shouldn't use the word list because a list is actually a different structure, but it's a sequence of values. all of our code up till now has been just using single bits of data. We have one person's BMR or BMI. We have one person's pay. We have one circle that we're trying to, keep track of the radius of and stuff like that. But really, computers process lists. That's really what they were designed to do, is to run through data, large amounts of data. So if you're playing a video game, inside the game, there will be a list of the shapes that are being drawn on the screen. You're playing World of Warcraft or, Call of Duty or whatever. You have all these people running around on the screen. Each one of them is in a list somewhere so that it can start at the top of the list, run down the list, and update the position of each one on the screen. Or if you have your phone and you want to send a message, so you open up contacts, you see a list. Or you're going to play an MP3, so you pop open your music app, you see a list of MP3s. You work for the Census Bureau, you have 500 million households on a database. You're going to run through them as a list. You're not going to just open up one person, So, anyways, to declare an array, the syntax is a little bit different than it was either in Python or in Java, for those of y'all who have had one of those classes. It looks like this. This nomenclature here, the square brackets, means this is not going to be a single integer, but it's a list of 10 integers. More correctly, it's an array of 10 integers. We now have 10 spaces to store scores into. So we could do this. The first score is a 99. The second score, well, we blew off studying, so we only made a 70. The third score, we buckled up and we made 100, and so on. We could fill all of these in all the way up to 9. We could not fill in score 10 because the array is 10 items long, but we start counting at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever the length of it is, we can only go out to length minus 1 as far as our index number. The number between the braces is known as the index. You know what? I don't feel like doing all 10 of them, so I'm going to change this to 5 scores. So let's say that I want to print those scores out. In some languages, it's incredibly easy to find out the length of the array. You could just do this, len or length, and you put in scores, and it'll tell you the length. Unfortunately, C++ doesn't have that option. It does have a slightly convoluted way of getting the length of an array where you take the size of the scores list and then divide it by the size of an integer, and it would tell you. But really, that is not something that you should rely on for once we get to that slide in PowerPoint. I'll say why. Really, we should just keep track of this number here, how big our array was declared to begin with. So what I'm going to do is I'm going to declare a constant up above that called num scores. And it's an int. I forgot to put the word int in front of it. Const int num scores is equal to 5. Then when I declare my scores, I'm going to put the word num scores there rather than 5. Now when I write my while loop or my for loop or whatever, I can use num scores as the upper boundary. For int I is equal to 0, I is less than num scores, I plus plus. Now let's get that score and print it. Cout scores I. And assuming I don't have any syntax errors, that should print out all 5 of those scores.
6 we're covering?
Actually, I do not believe it is. We are jumping ahead.
So this stuff isn't going to be on the exam.
On the final. Where are the rest of our PowerPoints? Why do we only have 3? Yeah, so chapter 6 is actually functions, but we've actually kind of talked about functions. Chapter 7. Come on, load it up. Arrays. So we skipped ahead to chapter 7. All right, so when I ran it, it printed out in order 99, 70, 100, 90, and 80. Comment out each one of those 5 calls, and then run it again. You might have expected it to print out zeros. In other languages, they would have been, whoops, I forgot to comment mine out. That's not at all what I was expecting. I'm going to cheat and comment them out with a multi-line comment. Put the slash star up at the top, the star slash at the bottom. There we go. Now when I run it, it comes out with that crazy number. At least it's a very specific crazy number. But if we had not compiled this in debug mode, if we changed the switches to create an executable with no debug information in it, then these numbers would essentially be random. They would be whatever was in memory at the time. So you have to initialize your array before you can do anything with it. There are 2 ways of initializing your array. We went ahead and just filled in every single value, so it wasn't a problem. But we could have initialized it before we started filling it with any data. And it's a reasonable thing to do to initialize it all with zeros. 2 ways of doing that. So of course we're going to do the hard one first. For int I is equal to 0, I is less than the num scores, I plus plus, and then scores at position I, index value I is equal to 0. So that runs to the list and it sets them all to 0. And I would want to do that if I wasn't sure that we were going to be filling in every single value. What if we were asking the user to fill in the scores, but we offered them the option to exit early, like one of those -1 to break kind of things? Then we wouldn't know that the entire array had been filled up with valid data. And so it's a good idea to initialize your data to 0. But there's a shortcut way, thankfully. Here's the shortcut way. Int new scores, num scores. And I can do this. I can use this little syntax. This means set them all to 0. So if we printed out new scores with a loop like that, it would print out zeros all the way through without us having to write a for loop to do it. Now this syntax is actually kind of designed not just for resetting things to 0, but to do something else. This is called using an initialization list to build your array. And notice that I didn't even specify a length for the array. Now this will look real familiar to the Python users. We were doing this all the time. But we didn't use those little square braces there. To make this look like the other ones, I would probably go ahead and fill in the number 3 there. But it's not strictly necessary. What that does is it creates an array, and the first number in it is a 3, and the second number in it is a 4, and the third number in it is a 5. Or I should say index value 0 is a 3, index value 1 is a 4, and index value 2 is a 5. If this had more than 3 values in it, if I said, okay, I want an array that's 100 items long, this initializes the first 3 values to 3, 4, and 5, and the rest of them are all filled out with 0. That's why this works. This specifically sets the first value of this array to 0, and then since we didn't give any more, the rest of them are also set to 0. Here, the first 3 values we have set, and then the other 97 would all be set to 0. So that's using an initializer list. So that syntax sets every element in the array to 0. This sets the first 3 values, 2, 3, 4, and 5. The rest of the array would be 0. And this syntax up here without an initializer doesn't set the values to anything. You have no idea what those numbers are going to be unless you then use a loop. So this declaration did not use an initializing list, so we have no idea what data values are in the scores array. So we use a for loop to set them all to 0. So an array is a variable that can store multiple values of the same type. Since I declared my arrays as being ints, I can't then turn around and store doubles in them, or strings. If I try, it'll give me an error. If I come down here and, let's see, I had an array called ages. If I decide that the age of the first person in the list is 10.5, it's supposed to give me an error. Fine, be that way. Okay. If I print it out though, it's not going to be 10.5. I swear it's just going to be 10. There. Huh. Oh, I know what happened. I didn't put an ENDL, so it showed up in the same line as something else. There we go. So ages 0 is equal to 10. That's because it is an array of integers. The only thing I can put in there are integers. If I try to put other things in there, it will go ahead and gamely try to convert it to an integer. But 10.5 is not an integer, so it got rounded down to fit in there. I certainly cannot stick a string in there. I can't do ages item 1 is equal to Fred. That won't even compile. C++ does know that you cannot put a string into an integer. There's just no way. You can't even cast it. That doesn't mean anything either. Or does it? The error is gone. What's it going to tell me? 199794008. I don't know how that equals that, but okay. Anyways, the only thing it can store is integers. If I declare an array of strings, I put strings in it. What's an array of strings looks like? Come down here and make another array. So right above my pause, I'm going to make an array of strings, and it's going to have 3 of them in there. I'm going to call it colors. And I'm going to set it equal to red, comma, blue, comma, and green. Now if I used a for loop, I could write a for loop that would go through there. For int I is equal to 0, I is less than 3 because I have 3 colors, I plus plus, C out the colors at that index value, followed by an end of line marker. There we go, and it printed red, blue, and green. This could be any data type. Any data type that C++ understands, I can turn into an array. Floats, doubles, longs, booleans, bytes, weird classes. We haven't been talking about classes, but you know, once you make up your own class types, then you could then put them into an array. So the values are stored in adjacent memory locations. So, what is going on behind the scenes when we create an array of integers? Is something like this. Say I do int AI for array of integers, and I go ahead and initialize it with 3 values. 3, 6, 10, 20, and 5. That means that it's got the numbers 3, 6, 10, 20, and 5. So inside the language, as it's running, it's got a variable named AI, and it's pointing to a memory address. Say that our array just happened to start magically at byte number 10,000 in our computer. And we don't see this number. We don't know that it's got 10,000 as its value. But it does. And then when we want to print this one, well, each integer is actually, I think, 4 bytes long. So this one is going to start at 10,004. And this one is going to start at 10,008. This one's going to start at 10,012. And this one's going to start at 10,016. Again, you don't need to know those values. Those are behind the scenes. It's just an array is a contiguous amount of memory that can be addressed in little blocks, depending upon what data type you assigned it. These are ints. If they were doubles, they would be stored in a different fashion. So, I don't think I'm going to take that any further than that. They are values that are stored in adjacent memory locations. That means it's very easy for them to get processed. An array is the most efficient structure that C++ has if you're going to be processing those series of values. There are other structures known as queues and lists and vectors and stuff like that, but those are not necessarily stored in a straight row. And so when the program is stepping through them, it might have to go over to one place to get that number, and then it might have to go to another place, and so those are not adjacent. It just means that when they're being processed, it's not the fastest possible way of doing it. They are declared using the square braces, like I have 5 tests, so this is an array of 5 ints. And somewhere out in memory, it creates a spot for 5 integers. So here, I'm going to make an array I'll do that. Int tests 5, like that. Let's print out the size of the test array. Size of tests. And then let's print out the size of an int. I'm just going to print out the number 1, because I know that 1 is an int. And I should put some kind of description here so that I know what I'm printing. So I'm going to add a little bit to this. Size of array, like that. And then size of int, like that. Size of tells us how many bytes are being used in order to hold that data. When I ran it, it told me that the array was 20 elements long, 20 bytes long. And then it told me that each byte takes up 4. I can figure out how many bytes, how many elements are in this array by dividing that number by that number. 20 divided by 4 is 5, and that happens to match that. So you don't actually have to hard code a number like we did here. I don't have to do 3 here. I could use one size of divided by another size of in order to figure out the length of the array. That doesn't work in every case. So I encourage you, when you do create arrays, the best thing to do is to create a constant as well that represents the length of the array, and then just use that constant. In other languages, I don't encourage that, because you can actually ask the array how long it is with a function that'll tell you. So that's the data type. Int is the data type. That's the name of the array. The thing between the braces, or including the square braces, that's known as the size declarator. That's a silly word, but I'm just going to say that it's got a size of 5. I won't use the word declarator again. So the size of the array is the total number of bytes allocated for it, which is really the number of elements times the number of bytes. Now this just argues with this definition. No, it doesn't. I'm not going to use that definition anymore. I'm not going to talk about arrays sizes being in terms of bytes. If I ask you the size of this array, the technical answer would be 20. But I'm going to use the word size to mean length, and the length of the array is 5. In fact, I probably won't use the word size much. I need to train myself to use the word length, and the length of that array is 5. Often people make constants to use the size declarators. Here we set a variable named size equal to 5 so that when we declare our array we can say that it's an array of length 5. It eases program maintenance when the size of the array needs to be changed. Your boss tells you, no, I want your program to be able to handle 10 tests. Well, they go in and fix that. They change that to 10. Whereas if they had 100 different for loops in the code, and they had put 10 inside of every for loop, or 5 inside of every for loop, then when you change the size of the array, you would have to go and change every for loop you wrote. Accessing array elements. You do so by what they call a subscript. I call it the index number. Our array of 5 elements is accessed via index values or subscript values 0, 1, 2, 3, and 4. So if you say that the length of the array is of length n, then the last element is n minus 1. This is an array of length 5, so we can access elements 0, 1, 2, 3, and 4, because that is 5 elements. If you try to access past it, it corrupts memory. Some languages won't even let you do that. The compiler catches it. Java is like that, for example. However, C++ is happy to let you write past the end of the array. So for example, go back to our program. We declared 3 colors, didn't we? Let's tack on a new color. Colors, element number 3, because we already know what 0, 1, and 2 are, is equal to purple. And colors at element 4 is equal to orange. I'm going to cut that for loop and paste it after those two. Now this is very bad programming. It may actually work. It might not even cause us any errors. But somewhere memory has been corrupted. We have written past the end of the array. We might be able to get away with it, we might not. I'm going to run this now, but I'm going to change this for loop to go ahead and say I want you to print out 5 of them. Just to see what it does. And it actually worked. We didn't see a problem there. But we did write past the end of the array, and so past this little area of memory, whatever data was being stored after that has now been erased and replaced with those words purple and orange. And in this case, there may not have been any data stored there. So we got away with it. But you have to try awfully hard to make sure you're not writing past the end of the array. And places where that happens, this is the most, an incredibly common way of hacking into programs, is by entering data that writes past the end of an array. Often a program is written in such a way that the data that is being typed in or that is being sent to it over the internet is stored in an array of characters. And usually, or quite often, those arrays have a fixed size. People used to make them 80 wide because the screen, the terminal, was 80 characters wide. Or other people always chose 255 because that was their favorite number, or 256 or whatever. If you fed it more data than 256 characters, then you wrote past the end of that array, you managed to corrupt some data, and if you did it just right, you might wind up changing the bytes in the program itself so that it would do something different than what the program had been written. That's called a buffer overrun. And a lot of Trojan horse programs or viruses or whatever are written to take advantage of that kind of problem. So you really need to make sure when you're writing your own code that you're not trying to write past the end of the array. And you should also try not to let the user change data that's past the end of the array. So once you have an array, you can just use those boxes in the array as though they're regular variables. I'm going to take out these 2 lines because it's a floating time bomb. I never know when it's going to cause that program to crash or not. Nowadays, that would not crash the computer itself, most likely, because Windows is pretty good about protecting the operating system from buffer overruns, but it's not perfect. But anyways, so if I want to print out my favorite color, cout my favorite color is, and then I can pick one of those colors and I just say which one I want, either 0, 1, or 2. Well, I like blue today, so I'm going to print out color number 1. Quit yawning, y'all. Y'all are going to put me to sleep. Okay, that's kind of interesting. Here I forgot to change my for loop back to only printing out 3 elements. It's trying to print out elements 4 and 5, and you can see that that's completely invalid data. So I am not writing past the end of the array, but I am reading past the end of the array, which is not a good thing either. So I need to change my for loop to stop at 3. But here we go. It printed out my favorite color is blue because it treated this just like it was a single string, because it is. We have an array that's a series of strings, but if we specify a value using its subscript by using its index number, then we're just using one of those values. So you can access the element with a constant or with a literal subscript. That works. You know, or you can use a variable, an integer. That's what we've been doing with our for loops. We tabbed I from 0, up to 4, or 0 up to 10, or whatever. So using a loop to step through the array. Here they have declared their array, and they said that array size is equal to 5. Then they declared their array. They said numbers is equal to an array of that size. And then they have a for loop. Int count is equal to 0. Count is less than the array size. Count plus plus. And they assign each element. They are initializing the array so that every element in that array is 99. Now when I did my little for loop and I was doing that, I set them all equal to 0. You felt like setting them to 99. And that's a good place to stop. Let's make a Dropbox so we can upload. This will be M. All right, go ahead and put your CPP file in there, and we're done. The exam will be open Saturday morning, so just get it done by Monday evening so I can grade it, and we can go over it on Tuesday.